name is Deja Perkins, and I am an urban ecologist and community engagement specialist at North Carolina State University. My research focuses on interactions between organisms in cities and how human social structures impact wildlife distribution in cities. I currently work with Dr. Karen Cooper and Crowd the Tap to engage people with projects to investigate home tap water for lead. I connect people with citizen science projects through SciStarter and a weekly live stream show called Make It Count Monday to highlight the variety of projects that anyone can participate in from anywhere. I was introduced to citizen science as a high school student through a project called iNaturalist. It wasn't until I was in graduate school that I was introduced to the idea of using citizen science as a tool for research. In my thesis project with Dr. Madhusudan Kati, I worked with the Triangle Bird Count to help map bird diversity across the Triangle region of North Carolina. With the help of our community participants, we were able to sample birds in a variety of habitats and land uses in 5 cities. Upon looking at the data, we were curious if our Atlas-style protocol was similar to or just as effective as other crowdsourced datasets like eBird. eBird is an online website and web app that allows anyone to submit bird observations around the world. Birdwatchers like me often use eBird to keep track of their yearly and life lists. Researchers use eBird checklist submissions to provide data on bird populations and to answer bird-related questions. Originally, I was curious if the bird diversity in Raleigh was different from other cities across the US because of its high density of tree canopy cover. I was drawn to NC State partially because it had the most trees I had ever seen on a college campus. In fact, growing up in the city of Chicago and traveling around the southeastern US is why I became an urban ecologist. But I had never seen as many trees in a city as I had in Raleigh. I was curious if I could see a difference in bird diversity between Raleigh and other cities that were not as forested. Upon mapping the data from eBird, I realized that when looking across the city, there were certain gaps where we were not seeing bird observations. Now, this did not necessarily mean that there were no birds located in those areas, just that the people who submit checklists are not observing birds in all areas across the city. After having taken a special elective environmental justice class, I was curious how much wealth or income are in the areas that are being sampled. After merging in an income layer into the geospatial tool ArcMap, I found an interesting pattern indicating that many of our eBird observations were located in high-income areas. We had to rethink. Maybe our protocols or our methods were not as great as we originally thought at such a fine scale. Now on to question 2. Was our Atlas-style method as effective as eBird at this scale? Based on what we had seen so far, we didn't think so. It had to be better. Our protocol was based on a methodology in other counts like the Tucson Bird Count, which created a survey protocol for sampling cities in a 1 kilometer by 1 kilometer grid. Within that grid, they randomly distributed points, ensuring that each box on the grid had 1 survey site. My advisor, Dr. Madhusudan Kati, replicated this method and turned it into a citizen science project for the Triangle region. He created a new model where you allow participants to choose where to go to sample or participate within a selected area. Triangle Bird Count participants were able to choose from over 900 sites across 5 cities. They could explore locations close to home, nearby their favorite locations, or in new areas they had never explored before. When allowing participants to choose locations, where do they naturally gravitate towards? Comparing bird data from Tucson Bird Count and the eBird checklist, we saw that the Atlas-style method was able to capture a more accurate depiction of the birds in the urban landscape. The Atlas counts were detecting higher richness and sampling more unique locations than eBird. Now, of course, we have the question of why. The scientific process is never ending. If you do it right, there are always more questions to uncover. Now, why were eBird checklists oversampling the higher income neighborhoods? Was it because of the biological luxury effect? The biological luxury effect states that higher income areas tend to have higher species richness, or increased diversity of birds, and increased amounts of native species. Or were there gaps from volunteer bias? Were birdwatchers sampling most often in the locations they feel comfortable with? Did the racial bias of birdwatcher demographics being dominated primarily by older white women cause the gaps in the data? We aren't 100% sure, but Both are highly likely based on how we know racial and social justice impacts the natural landscape. Shell et al. 2020 reviews how historical, systematic racist practices, such as residential segregation, enacted in part through redlining, have led to unequal distribution of nature within cities. These inequities continue to play out in both the ecological processes of cities and the welfare of the residents. Urban social inequality stems from historical and contemporary power imbalances, producing deleterious effects that are often intersectional, involving race, economic class, gender, language, sexuality, nationality, ability, religion, and age. For example, various ecological attributes in cities are principally governed by the spatial and temporal scale of social inequities. For instance, the unequal distribution of urban heat islands, vegetation and tree canopy cover, environmental hazards and pollutants, access to healthy waterways, and the relative proportion of native to introduced species are strongly dictated by structural racism and classism. I think the biggest takeaway from my thesis work is that we need to be careful and ensure that the data we collect from crowdsourced datasets are unbiased and accurately captures the study area. When we use biased data, we miss key information on underlying social factors that influence how ecological processes in cities play out. By pointing out the gaps, we can figure out where we need to do better. Sometimes, when we have the ability to work at international and national scales, we forget to look a little bit closer to home at how things are interacting in our own communities. Not all methods work at all spatial scales, and that's okay, as long as we figure out a way to do better. I think that's also a part of science in general, thinking about how to constantly do better. The results from my thesis show that atlas-style sampling protocols are the way we collect better data. Citizen science is a powerful tool that allows the public to monitor the environmental conditions in their own backyards. By intentionally engaging people of all backgrounds and socioeconomic statuses, we can ensure that we collect data from all communities, even those that don't currently report data. Only by capturing the conditions of those most affected by environmental hazards can we complete the picture of the urban landscape.